You just bought a new device and you're adding it to your Wi-Fi network, and you see all these network settings show up, like IP address, subnet mask, router or gateway, and DNS. Then you wonder, what is that subnet mask? Well, in this video, you'll find out. Welcome back to Dev Odyssey, a developer's journey through IT, where I cover tutorials and reviews of IT tools and technologies. I'm your host, Orest, and in this episode, we're covering subnet masks. So I've done quite a few videos that involve networking, but we haven't covered in depth what a subnet mask is. A subnet mask is a number that defines the size of a network, or a subnetwork, with a range of usable network IP addresses. As a result, a subnet mask designates how many devices are allowed to be on the network at the same time. A subnet mask also helps your devices create routes, so network traffic can leave your device and reach its intended destination, whether it be on the local network or on the internet. So then, what are subnets used for? Well, a subnet helps relieve network congestion and improve network performance by putting devices onto different networks, as opposed to the same network. Subnets are also used for network segmentation to help secure devices that shouldn't be on the same network, like those pesky IoT devices. Now that we know what a subnet mask is and what a subnet is used for, let's figure out how a subnet mask works by drawing it out together. In this example, we're going to take a sample IP address and network mask and show you how it works. First, we convert the IP address and the subnet mask to binary. Next, we see that the first three octets of the IP address, or numbers separated by periods, are masked by the first three octets of the subnet mask. They are masked because all the binary bits of the subnet mask are ones. This means that this portion of the IP address is not allowed to change for this network. The last octet of the IP address is not masked by the last octet of the subnet mask. They aren't masked because all the binary bits are not only ones, but rather a combination of zeros and ones. This means that this portion of the network is allowed to change and is referred to as the host ID. The range in bytes in the last octet of the subnet mask also define the size of the network. Therefore, written back in non-binary form, the first three octets of the IP address are static. The last octet is dynamic and defines the host ID and the size of the network by showing us how many host IDs are available. We could think of 255 as locking in that octet from changing. Anything less than 255 and the difference from 256 is the network size. To figure out the network range, or number of available hosts, we need to take the network size and subtract it by 2. The first IP address is reserved for the network ID. This identifies the network to devices. The last IP address is reserved for the broadcast ID. This allows devices to communicate with all devices on the network. Therefore, the number of available hosts is 256 minus 2 equaling 254. Usually, the second IP address is the IP address of your router or gateway. You can more easily write the subnet mask in a different notation called Classless Inter Domain Routing, or CIDR notation. To show you this example, let's refer back to the binary version of the subnet mask we saw earlier. As you can see here, the first three octets are masked, or the first 24 bits. Therefore, the subnet mask in CIDR is /24. Now we can cover subnet classes more quickly. This is the old style of referring to network sizes, but is still used in terminology. A subnet class is where an octet stays constant. For a Class A network where the first octet is constant, that CIDR range is from /8 to /15. For a Class B network where the first and second octet are constant, that CIDR range is from /16 to /23. For a Class C network where the first, second, and third octet are constant, the CIDR range is from /24 to /32. A Class C network is what we've been working through in this example, and commonly used for home networks. Lastly, to get an idea of networks in different subnets, I'll draw out two different Class C subnets. These two are different subnets because the third octet is different in each, and devices from different subnets cannot communicate directly to another device on another subnet without going through the router. And that covers it for subnet masks and subnets. Thanks for following me in my journey. I really appreciate it. If you got some value out of this video, go ahead and give it a thumbs up. And if you like this type of content and other content around IT tools and technologies, networking, security, and more, go ahead and subscribe to my channel and click that bell for notifications so you don't miss the next video. What did you learn about subnet masks and subnets in this video? Go ahead and drop me a comment below and we could talk about it. Thanks again, and I'll see you in the next video.